Today, we're diving into a choice faced by pretty much every new electric vehicle owner. How to select the optimal level 2 home charger. It's a decision made particularly interesting, I think, by the, let's say, generous $5,000 budget, often available for both the hardware and the professional installation.
That budget certainly helps. It lets us move beyond just pure cost constraints and really focus on, function and maybe philosophy. Because the reality is, level 2 charging at home, it's practically mandatory for daily use these days.
Absolutely. Yeah, we're not debating the necessity of 240-volt charging here. The real question, the essential trade-off, is what defines the best charger within that budget. Should homeowners prioritize the cutting-edge, feature-rich smart technology for maximum future utility, maybe potential cost savings, or should they focus really intensely on proven rugged durability and guaranteed operational reliability? My argument is that maximizing those intelligent features is actually paramount for superior long-term value and energy efficiency.
I'm afraid I come at it from a fundamentally different angle. Complexity, however sophisticated it might seem, it just introduces points of failure. So my position is that reliability, ruggedness, fail-safe operation, these are qualities often compromised in complex, maybe cloud-dependent units. Those should be the decisive factors. Look, if the core function, charging the car, fails because of some glitchy app or, the Wi-Fi drops out, well, those advanced features are worse than useless. They're actively detrimental.
I do see the appeal of simplicity, I really do. But let's look at the tangible value that smart features and flexibility bring. The best chargers, they leverage reliable software to deliver essential functionality, and they easily justify their, $450 to $700 hardware cost. The primary benefit, really, it's financial. It's rooted in optimization.
Optimization only matters if the foundational charging process is actually reliable day in, day out.
Right, and with established high-quality brands, it generally is. The financial advantage comes from the scheduling capability. This lets users charge during low-cost, off-peak hours using what's called time-of-use pricing. So for our listeners, that means charging when grid demand is lowest and electricity is cheapest. That leads to substantial, measurable savings over the life of the vehicle.
Assuming, of course, that the smart layer accurately and, more importantly, consistently executes that schedule.
Precisely. And beyond just simple scheduling, we need to look at future integration. Take the Emporia Smart EV Charger, for example. It's frequently cited as a best value pick, costs around $399, specifically because it integrates with the Emporia View Monitor system to automatically charge using only excess solar power. Now, that level of optimization and, let's call it energy arbitrage, is pretty essential future-proofing for homeowners who already have or are planning solar arrays. It ensures every, joule generated gets used efficiently.
That is, I'll admit, an elegant feature on paper, but it introduces the risk of conditional charging. You're asking the homeowner to trade guaranteed overnight charging for the complexity of solar-based conditional charging. What happens if the solar algorithm miscalculates, or the cloud API, which these devices inevitably rely on? What if that fails? I just find it difficult to justify potential savings when the primary objective, getting a full charge when you need it, is suddenly contingent upon network status.
Well, I think that risk is minimized with modern load management features, which are, frankly, vital for safety, not just convenience. Advanced smart chargers like the Wallbox Pulsar Plus and the Tesla wall connectors, they offer intelligent power sharing or load management. This lets households with multiple EVs manage their consumption dynamically, preventing the charging system from overloading the main electrical panel. Now, to achieve that foundational safety and efficiency in a multi-car setup, you absolutely require a robust smart layer.
Okay, I agree that load management is a critical safety feature, yes. But that speaks to necessary functions that, in my view, should be hardwired into the unit's core logic, not solely dependent on a sometimes, let's be honest, glitchy mobile application. My core thesis stands: reliability must always precede capability. And the market's lowest-rated units, well, they illustrate the danger of complexity perfectly.
But we should be comparing the industry leaders, the ones getting it right.
not the outliers that failed.
We have to study the risks of complexity to choose correctly. The Blink HQ200, for instance, it has an abysmal user rating apparently because its mobile app and software are described as, quote, extremely unreliable. Scheduled charging fails, data isn't recorded. This isn't just some minor inconvenience. It completely negates the promised financial and optimization benefits. It just exposes the fragility of relying on cloud dependency for something that is, at its heart, about physical electricity transfer.
That failure, though, that sounds like a clear example of poor execution and, frankly, weak components, not really an indictment of intelligent features across the board.
But it highlights the inherent vulnerability of the architecture itself. A highly rated, reliable, non-smart charger is just preferable to a smart charger that's always offline or needing resets. Look at the Grizzl-E Classic. It gets high marks precisely because it's rugged, built like a tank, they say, with a heavy-duty aluminum case and a NEMA 4X rating, meaning it's completely weatherproof, durable for outdoor use. It achieves its reliability by prioritizing that structural durability over potentially glitchy smart controls.
But that ruggedness doesn't have to exclude smart operation. The problems of a unit like that Blink HQ200, they signal poor manufacturing confidence, right? Look at its very short one-year warranty. Meanwhile, you have established brands like ChargePoint, like NLX Juicebox, known for excellent smart charging features and utility integration. They prove that polished apps and robust scheduling do work consistently, delivering proven energy tracking and financial benefits. You simply cannot achieve optimal energy management without that reliable, certified smart layer.
I'm still not entirely convinced by that line of reasoning. The line between reliable optimization and potential catastrophic failure seems thinner than you might suggest. Even reputable brands, when they first introduced smart connectivity, have sometimes stumbled. We saw an early version of the Grizzl-E Smart, for example, introduce this odd quirk where the unit would just stop charging entirely if it lost its Wi-Fi connection. The fundamental function, charging the vehicle, must never be contingent upon Wi-Fi status. How can we fully trust a cloud-dependent device when its core job is so fundamentally physical? I prioritize the heavy-duty unit whose primary purpose is to safely and consistently transfer electricity, regardless of its network status at any given moment.
Okay. Let's maybe shift the discussion slightly from internal reliability to external compatibility, particularly concerning connectors. This is where flexibility and standards become really key.
And rightly so. And I think simplicity wins here again. The SAA J1772 connector, it remains the historical universal standard for all non-Tesla EVs, and it's still arguably the safe bet for broad compatibility. For multi-EV households, leaning toward universal J772 chargers just makes sense, especially since Tesla owners get that small adapter with their vehicle anyway, ensuring they can use any J772 station. Why introduce engineering complexity when simplicity enabled by a free, factory-supplied adapter already achieves full compatibility?
That's a valid argument for, let's say, market stability, sure. But I would frame the choice differently. It's about minimizing the inconvenience of fiddling with proprietary adapters while also future-proofing for the ongoing market transition to NACS. Relying on a small, loose adapter for daily charging is, well, it's inconvenient, and it's potentially prone to being lost or damaged.
You're perhaps focusing on a minor inconvenience rather than the potentially major risk of betting on a specific, complex integration method.
Well, the material suggests the market is already offering superior solutions here. Look at the Tesla Universal Wall Connector. It achieves true integrated flexibility with a built-in tethered J7072 adapter, what they market as the Magic Dock. This unique integrated engineering solution eliminates the need for separate loose adapters entirely. It makes it truly plug and play for mixed EV households, regardless of whether the vehicle uses the older J7072 standard or the newer NACS connector. This superior convenience, I'd argue, is achieved through advanced engineering, not complexity just for complexity's sake.
That is certainly an impressive technological solution to the compatibility problem. I grant you that.
It's more than just impressive. I think it demonstrates manufacturer confidence in their complex unit. That specific connector comes with a superior 4-year residential warranty, which is better than the industry standard 3 years. This longevity guarantee suggests that durability isn't necessarily being sacrificed for integrated complexity.
That warranty is an important data point, yes, but it pivots us perfectly to what I see as the ultimate determinant of long-term quality: the physical build and, critically, safety certification.
I agree completely. Top-rated smart chargers offer robust warranties. We see 3 to 4 years, with Tesla leading at 4. And mandatory certification, UL or ETL listed, that ensures manufacturer accountability and adherence to safety standards. Units like the compact Wallbox Pulsar Plus, they are highly durable, often achieving NEMA 4 enclosure ratings, making them perfectly suitable for outdoor rugged mounting. It proves that smart features and durability can coexist.
But the build quality itself must minimize the need for warranty claims in the first place. My concern is that consumers, maybe seduced by a long list of smart features, might overlook fundamental structural integrity and safety aspects. We absolutely have to flag the crucial red flags to avoid, even when someone's spending well within that $5,000 installation budget. This includes, those cheap, no-name, generic imports you often find online that lack proper UL or ETL certification.
Oh, the lack of certification is absolutely a non-negotiable safety risk. Yeah.
Exactly. That lack of oversight often leads to compromised thermal management, the unit's ability to handle heat safely, which results in serious risks like overheating, melting plugs, or tripping breakers constantly. When you're considering build quality, things like cable thickness, the rigidity of the casing, these are paramount. It's just crucial to prioritize a heavy-duty, certified product, like the Grizzl-E Classic again, which is specifically praised for being built like a tank. It handles high amperage reliably because it prioritizes that structural integrity over maybe fleeting software convenience.
Look, the premise isn't that quality should be ignored. It's that the smart units from reputable manufacturers do meet those high standards for certification and enclosure ratings, while also offering optimization. So the homeowner operating well within that $5,000 budget, they should seriously consider prioritizing the advanced capabilities offered by top-rated smart chargers like, say, ChargePoint, Emporia, or that Tesla Universal Wall Connector. These units offer tangible, compounding economic benefits through optimized time-of-use scheduling and, importantly, vital multi-car load management. They're designed for modern energy needs, plain and simple.
And I maintain that the inherent risks, and frankly, the frustration associated with poorly executed smart technology, exemplified by those chronic failure modes rooted in cloud dependency, argue strongly for prioritizing operational consistency above all else. The best long-term investment, in my view, ensures that the primary function, charging the car quickly and safely, is never, ever compromised by a temporary network outage or some faulty app. Reliability. That's the ultimate long-term feature.
So ultimately, the final choice really depends on the homeowner's own risk assessment, doesn't it? How much complexity are they willing to tolerate for potentially maximum energy optimization and future-proofing?
Exactly. Whether someone is seeking the most interconnected, energy-optimizing device possible or the most dependable, absolutely no-fail charging unit they can find, the source material confirms that a best-in-class, professionally installed solution is achievable within that budget. The key is really understanding whether you prioritize the smartest charger or perhaps the most guaranteed one.